Good morning, everyone. Please don't forget to resubmit your quiz number 12. And there is a deadline, so it's going to be and it's going to end on April 7th, 2021. So please do that resubmission. Thank you so much. And this technical problem, and I don't know how it's been, I vaguely suspect that might be the reason, but I'm not sure. But anyway, so let's get started on 19A. And you guys should, should review the whole thing. And I think today's lecture will actually help you to review for midterm exam, okay? Section basic 19A, okay? This is the section that we are to determine the domains for each one of these functions. And to determine the domain of these functions, the important thing to know is that we understand the domain of the basic functions. Okay, so please refer to basics 1, that table. Okay, in that table, we have talked about the domain and range of each one of those functions. And that is basically the foundation for basic 19A. Okay, for example, the first one is pretty straightforward. It's a linear equation. It's a linear function. The domain is all real numbers, right? The second one is a quadratic function. The domain is all real numbers. And here we're not going to worry about the range, even though we could, but we focus on determining the domain. Number 3, for example, right? Let's start from a simple example, number 3, that we have f of x equals to 2 over 3x minus 1. Okay. What will be the original model to determine the domain for this function? It would be the function in basic 1, which is 1 over x, right? So I wish to make a point here is that when you see a function like this, right? When we see a function like that, to determine the domain, of course, you guys can determine that domain with or without that reference. But I want to bring that reference into the picture because all the domain determination will have something to do with the original function and the original basic function, right? So you see in this function, right, 1 over x, the domain is x cannot be equal to 0. X cannot be equal to 0, right? So that's referred to, right? Even though this is a very simple reference, but the point I'm making here is that this is true for every function you study here, but sometimes you have multiple functions in the function in consideration. In that case, you have to consider the multiple functions and their domains. But all of these domain determination is based on basic 1. So whatever basic 1 tell us, so here you can imagine this is going to be something I call baloney, right? So baloney cannot equal to 0, right? And so the domain would just be the baloney 3x cannot equals to 0. And then we solve that inequality. Okay, so we set up, right? Then we solve this inequality. And what we end up with is x cannot equals to, we're adding 1 on both sides, divide both sides by 3, so x cannot equals to 1/3. So in the end, you just tell the reader the domain is x cannot equals to 1/3. The implication implication. Okay, so we write in this shorthand notation, but the meaning is x can be any real number, but 1/3. Right? But 1/3. You can take that off, take that away. All right, so this is how you determine domain. This seemed to be rather simple. Rather, you refer to the basic function, you don't refer to the basic function. Just imagine if you refer to the basic function, I think everything looks much simpler. Okay, so let's look at number 4. Do you guys want to try number 4 with me? Here we have a g of x, and that equals to the square root of 16 minus x raised to the power of 4. By the way, a lot of these questions, I would say more than half of these questions are actually from calculus textbook. They are from calculus textbook, and some of them are in the review section. Some of them are not from the review section in the regular chapters. And those functions will be considered in your finding limit, finding continuity, derivative, and those sections. And sometimes, well, when the domain is considered. So domain was part of, calculus questions. Okay, so every function has its domain determined. Every activity we do is inside the domain of that function. So that is a major theme that you're going to be, working with the moment you enter calculus. Okay, you work with function. We talk about the definition of function, and for every function, of course, there's a domain and range. So it comes to us naturally in those studies. Okay, in those studies. So now, how do we determine the domain for this one? And of course, we can refer this to a basic function, which we have learned, right? Refer to that basic function, square root of x, right? What is the domain for square root of x? What is the domain for square root of x? Or for that matter, we just go straight to bologna. Anything taken square root, okay? In your calculus classes, calculus 1, 2, 3, it's all about real numbers. It's all about real numbers. Okay, so complex number will not be considered. So in this case, the domain is, do you guys still remember the domain for square root of x? Let's see if there's any comments here. Are you guys awake? Are you guys awake? It's a good thing we have a recording, right? It's a good thing we have a recording, so you can watch it over, or if you miss any part. The domain is at least 0. Okay, the domain is not a positive number. It's a non-negative number. Okay, if you want to put it in words, it's a non-negative number, including 0. So if you don't include 0, then you'll be, that's not correct. That's not correct. So you would refer to this function. You don't have to refer to it directly. It's just mentally. It's a mental process that you refer to these functions. Okay. With that reference, you take the whole of it, because the whole of it is really omega. The whole of it is that. Okay. And you can, of course, view this as a composite function, but we're going to talk about those later. And here, whatever in the place of omega must be greater than or equal to 0. So that's how you set up. That's the setup. You don't have to write the word setup, okay? But that's how you set up. And then solve. Solving this inequality, okay? Do you guys know how to solve this inequality? Please try. Please try. You guys try to solve that inequality. Yeah? Are you guys working on it? Please try to work out that domain. What you get? There are multiple ways to solve this inequality. Okay, there are multiple ways. There are multiple ways to solve this inequality. Okay, so how do we solve that inequality? Would it be x is greater than or equal to plus minus 2? That's very good. Can you show some steps? Can you show some steps? Anybody would like to show some steps?
Did you want me to type out my steps or can I?
You can write it on paper and upload.
Okay.
You said, would it be x greater than or equal to plus minus 2? Anybody want to show your work? Okay. This is something I think you know how, you probably know how to do it. And there are many different ways to do it. Okay. So we have I'm going to copy and paste this posting on the on that. Okay. So if you like to explain to you what you meant by that and mathematically, I would love to see it. Plus minus 2. I would like to have an elaboration of that because I just wonder if this is what you meant. Okay, x is greater than or equal to plus minus 2. Is that what you meant?
Yeah, that was my answer.
Everybody, is that what you meant?
Yeah, that's what I meant.
All right, anybody else? I want to see the steps. I want to see the steps. Right. I think we get some pronto upload. Thank you.
You can use me as an example if it's wrong. It's okay.
Thank you. I really appreciate that. Okay, so I'm going to download that. Let's put on a new share. All right, thank you for sharing that. Okay. All right, everybody. I'm going to explain to you these steps. I'm going to explain to you these steps. Are you ready? If you have different steps and you wish to share with us, that'll be great. Okay, that'll be great. Now, I'm going to check his work step by step. Okay. First, he subtracted 16 on both sides. You get a negative x to the power 4 less than equals to, well, it should be greater than equals to negative 16. And then he divided both sides by -1 and he switched the direction. He actually did it right. Okay, from this step to the next step. Okay, any questions? He did not make that mistake which often happens. Okay, he did not make that statement, which happens often. Okay, that's good. That's good. And after that division, wait. Let me double check. Okay. Negative x squared, so greater than negative 16. No, he did make that mistake. He did make that mistake. You made that mistake here. When you subtract 16, you switch the direction, didn't you? Did you switch direction?
When I subtracted 16, I did switch the direction.
You should not switch direction. When you're adding, subtracting, you don't switch direction.
Okay.
Okay. So if that's the reason you switch, then this will be a mistake as well. But then you divide both sides by -1. So this should have been negative x to the power 4 greater than equals to negative 16. It should be greater than equals to, but when you divide by -1, it's less than equals to. So that switch actually, that switch is right. Okay. But in your mind, what you're thinking is not.
Got it.
Do you follow me? Okay, I'm going to explain this step when we go back to our other lecture. And then what he did is he's switching here, and that switching is one step behind what he did here. So he has already switched over here. You should not switch here. It should be less than, or equal to here. Okay. All right. Okay. So next, provided he's solving this piece of inequality, the answer, if he's solving this inequality, the answer is wrong. But you have shown us a lot of these common mistakes. Okay. I would like to have everybody, if you could take a picture of, or you can write it down what this piece of work is, and I'm going to go back. Okay, I'm going to go back and explain to you each one of these, common mistakes and common steps. All right, are you guys ready? Yeah.
Yeah.
Okay, Everybody should have access to this picture, right? Because I'm going to put it away, but I probably will type it anyway. Okay, so I'm going to put this picture to the side of my screen. I have two screens, so that make it easier. Okay, and I'm going to share another screen, which is we are coming back here. I'm just going to reproduce his steps. 16 minus x to the power 4. And thank you for sharing that, Cortland. That's very, very helpful for me to explain. Because if I only just show you the right steps, what's interesting is that when I always show with people the right steps, people just get used to the right steps. When they do it, they still make the mistakes. You know what I mean? That's what I see very often. Okay, that's what I see very often. Okay, and then the next step, and of course he subtracts 16, he has negative x to the power 4 less than equals to negative 16. The way he shows it, okay, I'm gonna put it here, minus 16 minus 16. Okay, all right. I want everybody pay attention to this, okay? Everybody please pay attention to this. And the next step he showed -1. He divided by -1. And then he switched. He has the root of x to the power 4. And then he switched. He certainly did a lot of things correctly. For example, the square root, wait. You took a square root there. You took a square root there. Well, that's another mistake. That's another mistake. But anyway, okay, so I'm just going to copy your work. I'm going to explain to the class. I'm going to explain to the class, okay? So the absolute value of x greater than equals to 2. And then he says x is greater than or equal to plus minus 2. Okay. When he subtracts 16 on both sides, this is correct. But the consequence of this subtraction, okay, the consequence of this subtraction is negative x to the power 4 greater than or equals to negative 16. You follow me? Okay. But he switched. Do you follow me? In his mind, he switched. But why do I judge this step as correct? Because when he switched, I'm sorry, when he switched, that's when he divided by -1. When divided by -1, this should have been switched. Do you follow me? But he didn't realize that. He switched it and he switched it again. Okay, so you can see these two steps are the same, but his thoughts going there was different, right? When you add and subtract on both sides of inequalities or equation, you don't switch, you never switch. Only when you divide or multiply by negative, you switch. Do you follow me? Did I explain that to you, why we do that? Okay, so I'm gonna make some comments here, okay? I'm gonna make some comments here. Okay. My way of writing this is a little bit, is it confusing? Okay, I'm gonna put it on 2 columns. Okay. And that one, that's what I inserted there. I'm gonna put it over here. Okay, so these are his steps. These are his steps. Okay, he put it here. Okay, these are his steps. So when he subtracted both sides by negative when he subtracted by 16 what he should have that. This is what he should have, but he didn't show this step. He switched. You follow me? But that switch, as a consequence of that switch, and then he divide both sides by -1, he thought, and then he switched on the next step. Do you follow me? That's why this step accidentally coincided with the right step here. Does everybody follow me? But of course, because that's the work you show, I have given you the reason. So this step is right from here after subtract 16, but he did not show this step. But this should have been what was done before dividing by -1. Is that clear to you, Cortland? Yes? So I'm going to put a note here. When adding or subtract the same number on equation or inequality, equations or inequalities, never switch. Never switch. Okay? When multiply or divide by a negative number on inequalities, switch. I don't want you guys to have to memorize these things. I don't want you guys to have to memorize things. So what are these related to? Let's elaborate on the first sentence. On principle number 4. On principle number 3 and number 4. Principle number 3, what does it say? If A the same as B, then A plus C is B plus C. Yes? Do we have this? I want you guys to look at that principle. Okay, I told you at the beginning of the semester, everything you do should not violate these principles. Okay. Now, so when we add, would it be the same if you subtract it? So plus or minus. But because C is any number, so really it doesn't matter. That's why we use plus. Do you follow me? So this tells you, then you say, well, this is the same. What if there's inequality? Inequality is the same thing. Okay, inequality is the same thing. When you learn the basic addition subtractions, right? You have learned how it be shifted on the number line in pre-algebra. So that's why. So when you add or subtract, no switch. Okay, it's the same thing with larger than equals to. For example, if A is greater than B, then A plus C is going to be greater than B plus C. You're adding the same number or subtracting the same number, right? You're adding the same number or subtracting the same number. And if A is less than B, then A plus C is less than B plus C. All right, so when you're adding or subtracting, it's just simple matter of shifting. Do you follow me? On number line, when you're adding, it's shifting, maybe shifting to the left or shifting to the right, depending on you adding a positive number or negative number. So these relationships don't change. That's why this sentence, do you follow me? So principle number 3, even though we did not talk about inequality, but it was implied. It was implied. And now we added to them, right? You can say these are the additional. Now, principle number 4. Can anybody tell me what's principle number 4? If A is the same as B, then AC is the same as BC, provided that C is not 0. Then you say this is about equation. That's true. That's about equation. Okay, this is about if statement, right? We're all talking about these are if statement. Okay. However, for inequality, for example, if A is larger than B, then we still have AC greater than B times C, provided C is not 0. Do we have this? Do we have that? This is a false statement. This is a false statement. Okay, so this is false, and you guys know because from your work, I know you have done the switch. I'm just explaining to you. I want to explain to you why the switch. Why is the switch? Okay, less than B, then AC less than BC, provided C is not 0. So these, okay, what is true? Okay, so let me list it. What is true? If A is larger than B, then AC is still larger than BC, provided C is larger than 0. When you multiply a positive number on both sides, this is true. True. Okay, so I'm putting these principles here. I want you to think about it. I'm going to explain to you why. Are you ready? Yeah? Now I'm going to put still greater than, okay? Still greater than. If A is larger than B, then AC will be smaller than BC. If C is less than 0. And here's why. Here's why. Right? Look at the number line. Okay, look at the number line. Look at the number line. Okay, this is my number line. Okay. Could I say 3 is larger than 2? Yeah. 3 is larger than 2, right? Suppose this is 2 and that is 3. 3 is larger than 2. Does everybody agree with me? Sure, that's obvious. But what if I multiply this inequality on both sides, multiply -1 on both sides? What do you get? You get -3 on one side, and you get -2 on the other side. Yeah? Is -3 still larger than -2?
No.
No. Switch. Because -2 will be what? Will be here. -3 is here. You follow me? This is the reason why when you multiply by negative, you switch. Is that clear to you? Once you understand the why, you never have to remember. Do you agree?
I agree.
Yeah. When you understand the why, you never have to remember. You never have to memorize. Okay, but in most of you, so now you know the why, right? That's why principle number 4, when it applies to inequality, is no longer true. And this will also serve as the counterexample to these false statements. Okay, so what are the true statements? The true statement are these two. When you multiply by positive, you don't switch. When you multiply by negative, you switch. Now, in execution of these principles, I believe most of you know these principles. Now you understand why, you know you don't have to memorize, which is great. But in execution, there are a lot of common mistakes. So I want to, and the work I've just shared with us, I really, really appreciate that, have demonstrated that, have shown these common mistakes. Okay, so let's go back to the work that we just worked with. Right, let's go back to the work we worked with, right? So when he subtracts 16, he should have got this one. There should be no switch. Do you follow me? But he switched. Divide both sides by -1, he should have switched. He didn't. He switched on the next step. That's wrong. You follow me? Does everybody follow me? But because of that he postponed that step and he switched earlier, so he made that accidental correct. Okay, so had you shown this step here, Portland? Had you shown this step here? Okay, had you switched here? Had I see this? You will lose more points. Got it? So this is, got it. Okay, very good. So now let's continue. Okay, what he should have get, okay, at the end of all these operations, okay, should be x to the power 4 less than equals to 16. That's what he should get. But I'm going to talk about these later. Okay? Because usually when your professor grade your work, after he or she found the first mistake, and she or he will not continue to look. Yes? That's a common practice. When we identify your first mistake, okay, what is his first mistake? His first mistake was here. He switched. He switched a step after. You follow me? So this is his first step of mistake. Now, I will come back to this, that he should have gotten this. Because after that first step of mistake, we're not going to continue to look. And the next step he did, from what he got, he should not be taking a square root. He should be taking a fourth root. He took a square root. He should have taken a fourth root.
Yeah, sorry.
Only after he takes a fourth root, he will get the absolute value of x less than or equals to 2. So the answer would have been -2 less than or equals to x and less than equals to 2. This would be the right answer. Okay? Do you follow me? So now in summary, okay, so I'm going to show this, show work. Okay, because all of these are discussions. If you are to do the work, and you show these work to the professors, and these are the recommended steps I'm going to show you. Okay, suppose this is a piece of work I turn in, and I would have done this. Show work, I will set this up, and I will show that. I will simply add x to the power 4 on both sides. So I get to this step, and that, and that, and that. I'm done. Do you follow me? So this will be there will be a version. I would say this is a version of correct work, because I don't want to keep you waiting for too long. That's okay. Long way, short way, it's fine. Okay. What you need to understand, every step you show is scrutinized. That's our job. That's your teacher's job. Okay, and every step has to be justified, whether you take long step, you take short steps. So did you guys write it down, this piece of work? There are many different ways to do this, and I will show you later. And the purpose of doing this, I want you to make connections. And try these different ways will improve your algebraic skills, which we all need, right? All right, did you write it down, this piece of work? This is only a version of correct work. Okay, it's just a version of it. Okay, so next, I want to comment on this piece that he did. Okay, this piece, if he has taken square root, he should get x squared greater than or equals to 4. Okay. And the next step, he will have to take another square root. You have to take the square root one more time. To get the 2. Do you follow me? Just by taking square root, you're not getting there. You're not getting to absolute value of x is greater than or equals to 4. Okay, then you get to the next step. Do you follow me? So from here, you should have put a 4th root, okay? Or you take square root twice, okay? But when you get to this step, okay? So I'm gonna make assumption, if you got this, I mean, in this case, you shouldn't get here, right? You should be getting less than or equals to 16. If this is the case, so that's why I'm going to put an if, okay? Because after that step, he was completely wrong. So we're not going to do, but there are certain pieces that I want to point it out. So you get to this place. From this step to the next step, this is a terrible mistake I want to point out. This is a terrible mistake. I don't know where you learned this. And I still appreciate how much I appreciate you share this, but this is a very common mistake. Please, 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 please don't do this. Which is covered in basic 4, 5, 6. Can you guys go back to basic 4, 5, 6? What should you get here? I don't know. I really don't know where you learned this, but you have to dig deep. Why you will keep doing this? This is one of those horrible mistakes. I don't know how much I emphasize to get your attention so you will not do it again. Why? Because the correct answer, okay, the correct answer is x less than or equal to -2 or x is greater than or equals to +2. This is the right answer. I simply don't understand why people keep doing this. And this statement is totally different from that statement. Okay, this statement is saying, okay, I don't know. There's no clear definition in mathematics about this statement. When a certain statement has no clear definition in mathematics, that statement is going to be out of mathematics. Do you follow me? Because every mathematical statement has to be unambiguous, has to be totally clear up in its meaning. It cannot have ambiguous meaning, okay? So the possible interpretation about that, okay? You never see anything like this. At least I haven't personally seen anything like this written in any textbook in my limited reading of mathematical text. Do you follow me? Well, if you have seen it, please let me know. I would like to see, I would like to learn what will be the interpretation. Okay. One of the interpretation would be saying x is greater than or equals to 2, +2, or x is greater than or equals to -2. This is one interpretation. And the other interpretation could have been, it's an and. I kind of assume that I might have read more mathematical textbooks than you do. Could I assume that? I have never seen anything like this being written. So wherever you learned that or you invented that, so please get rid of it. Could you do that for me? Could you do that for your own sake, for getting some points? Okay, if this is the case, okay, let me tell you why it is false further, so you fully understand your mistake. Okay, because the implication is profound. Okay, so now first look at the correct answer. Okay, let's look at the correct answer. For the correct answer, remember I drew a number line. Okay, so I'm going to do number line this way quickly. Okay, so this is a -2, +2, right? When the absolute value of x is greater than or equals 2, that means this is the answer and that is the answer. Yeah, on number line, these are the answers, correct? They're in red. Okay, that's what it means. Now, what does this mean? What does this mean? This means x greater than or equals to 2. X greater than or equals to 2, meaning I'm still going to put a number line here, 2 here, number line. Okay, greater than or equals to 2 means that, oops, sorry. Okay, red. Greater than or equals to -2. I'm just showing you how your work will be scrutinized and why it is a mistake. Okay, so be patient with me. Then you say, well, because people will say, why don't you just tell us that it's wrong, we don't do it again? No, the question is you will do it again. The student will do it again and again and again and again. Okay, so that's why I'm going through these lenses to explain to you. So please don't do that. Okay, so when you OR this, when you have x plus greater than or equals to 2 or x greater than or equals to -2, this is basically two statement. Remember we learned the truth table about OR? Remember we learned truth table about OR? When you OR it, we talked about it yesterday, right? When you OR this, the consequence is what? The consequence is going to be x greater than or equals to -2. Think logically, please, you guys. When you OR this, that's what it means. You follow me? You end up with x greater than or equals to -2 because that's the nature of OR. Anything that is true, you only have to be true once. Remember the set definition I give you, right? Let me show you how you apply it. Truth table is easy, but when you apply it, it's different. This is your A. This is your A, okay? And this is your B. This is your B. Okay, so this is your A. A is in red. And this is your B, greater than or equals to -2, right here. Do you follow me? On interval, you're telling me, remember we have a homework problems with intervals? Okay, that's a 2 to infinity. B, the way we write it, greater than or equals to -2, that's going to be the same. -2, positive infinity. So when you do this guy, you're basically doing A or B. You follow me? So how do you divide A, or how do you find elements in A or B? Could you guys look at the definition? I'm thinking that as I'm doing this, I'm giving you valuable lessons. I hope it will be so valuable to you, because this is essential to understand in your future, for your future classes. Logic, discrete math, it's all here. Okay, so you must think logically. Okay, so now curly bracket. Remember that definition I give you? X would be what kind of numbers? X has to be in A or in B. You may not think this much when you do this. Okay, did you think this much when you did this? Probably not. But as a teacher, I have to think this much, the implication, because I need to give you a ultimate truth or false statement and making that connection. That's why in here, I have to give you the points if you didn't show that, right? If you show this, I'm sorry, the work you show here, that's why even though you think incorrectly, but you show the work correctly, minimal step, I have to give you credit. Do you guys follow me? Okay, so any judgment I make or your teacher make should withstand the test of time. So when we are grading your work, or at least when I grade your work, I take it very seriously. The judgment points I put on your paper has to withstand the test of time. Okay, you may think of this as just one semester, but not me. I'm thinking of my entire lifetime, your entire lifetime. That's how seriously I take this job. So please do pay attention to this here, okay? So now, let's keep going the or, right? So this is A and this is B. So if X is in A, X is here. If X is in B. And obviously, all of X greater than equals -2, they're gonna cover 2. Therefore, the consequence of X greater than equals 2 or X greater than equals -2, the consequence will be the final. That's the final. Do you guys understand that? As I'm addressing this example, this also is the clue. I don't know if you guys doing these homework. The homework I give you, which is basic, hold on, basic, I give you homework on basic 13, basic 16. This is basically the guideline for your homework basic 16. Okay, I don't know if you guys did it or not. These exercises are superb. If you do the way I told you, I show you to do in class, it's a superb exercise for your logic. Because you use it constantly. Okay, it's like dribbling the basketball in the basketball court. You dribble it. The more you dribble, the better you're gonna be. Now, the other interpretation, okay, is still A, B, but it's and. Okay, in the other interpretation, when it's and, this is and. The truth table and will come. So what happens if you have x is greater than equals to 2 and x is greater than equals to negative 2? What is the, so both conditions have to be satisfied. Are you guys thinking with me? Right? In this case of and, what will be your final?
X is greater than or equal to 2.
X is greater than equals to 2. Do you agree with that? Of course, because A and B is only true when both are true. So you only be left with that's a perfect answer, x greater than equals to 2. And these will not be included because it doesn't make the other statement true. Okay, so once again, you should go home and do basic 16 as well. Okay, I did only one example because, you know, I agree we didn't spend enough time there. But you as a student, you must do it. You must do it. Just because I didn't spend enough time because we didn't have enough time, you need to do it. Everything I do in this class, I personally resolve, I want to be very, very helpful for you, but provided you do the work. I cannot do every piece of work for you. You have to do the work. Okay, every little thing I put in this notes in this handout, I have spent a lot of time thinking, reflecting, and moving things around every semester. Okay. I'm not asking you guys to be grateful or anything. No, and I'm not asking it. I consider that's my duty, that's my work. But you must take it very seriously. Okay, so do you see the ambiguity of or and, right? So however read it, however we read this, which I don't know, I really don't know how this should be read, but such an ambiguous statement just has not shown up in any textbook I personally have touched. I went to college, I went to graduate school. I got some degrees. So I hope this telling will tell you, please, 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 please don't make this mistake. Is that enough? You see the obvious ambiguity, right? Now, does either ambiguity, does either interpretation give us the right answer? The answer is no. The right answer is right here. This is the right answer. Do you see that? That's the right answer. Either interpretation, the second interpretation, and give you x greater than equals to 2, or only give you part of this answer. The next one, the previous one give you greater than equals to greater than equals to, I'm sorry, greater than equals to -2, greater than equals to -2, greater than equals to -2 would include numbers that are not solutions. Do you follow me? So once again, I'm asking you guys, please don't make that mistake personally. I'm asking you that to do that. Okay. All right, so that's the number, okay, that's the explanation. I certainly understand when you give this answer, you didn't think that much. Now you should. So everything you put down on the paper, you have to understand, what do I mean? Is that what write it down? Mean what I meant. Because in mathematics, it has its own interpretation. Okay, but anyway, I hope this is helpful for you. And I didn't mean to bore you, but these meant to be very good lessons for you guys to learn. So I just give you one version of this work, and I promised you I was going to give you another version. So with all these commotions and explanations, okay, and I am going to give you another version. I'm going to give you another version. The other version is actually a little bit longer. Okay, so let me gonna give you the other version anyway. Another version. I have a reason to give you this version. Okay, so suppose we solve this inequality. Okay, we set up, we find the domain, we have this. The other version is just you factor. You make it 4 minus x to the power of 2 multiply 4 plus x to the power 2. The reason I'm making this, I want to present this version to you because I want you to make a connection. Make a connection with the methods taught in basic 9. That's the connection I want you to make. Do you follow me? And there's also some algebraic aspect, interesting algebraic aspect we can use here. Okay, so you factor. Does this look familiar? Right? And the next, we'll continue to factor because 4 minus x squared can be factored into 2 minus x times 2 plus x, right? Yes? Okay. So now the interesting part comes. This number is always a positive. I'm making a claim that this number is always a positive for any real number x. Why do I want that claim? Because I want to get rid of it. Okay? If this is always a positive times any two numbers that may be positive or negative, this is useless. Yeah? I want this to be positive or 0. I want this as a positive or if this is a positive or 0, if this is a positive or 0, this is a positive or 0. I want to make it simple as possible. So I'm going to divide both sides by 4 plus x squared. So if this is true, this is true. I understand that most of the students would not be thinking of doing this. I want to expose you to these. You still may not do it. Okay? But this is not beyond you. This is not beneath you. This is also not beyond you. Okay? In the process, I wish to show you how much flexibilities we have here. Just based on the 6 principles. Just based on the 6 principles. It's amazing. It's amazing. Okay, how much of flexibilities we have. From here or along the way, there are a lot of things you could have done. Okay, just set your mind free. Think about those things. For example, from here, you can use the sign. You can do the sign of 2 minus x. right? One doesn't change sign. Right? One doesn't change sign. When x is less than 2, when x is less than 2, it's a positive. Right? It's a positive. At 2 is 0. After 2 is negative. You can use that method. Do you follow me? Are you working with me? Sine of 2 plus x. Sine of 2 plus x. Okay? When does it change sign? Negative 2. Okay? One is less than negative 2. It's negative. One is equal to negative 2. It's 0. One is larger than negative 2. It's a positive. Math is interesting when you explore all these options. At the time you're getting better, you gain more insight and you see simplicity. Okay, so finally, sine of the product, right? Sine of this product. And you know the drill, right? You know the drill. So we have negative 2, positive 2, boom. You determine the sign. You guys follow me? Okay. So now when x is less than negative 2, it's positive times negative. So it's going to be negative. Wait, negative. At negative 2, it's 0. Between negative 2 to positive 2, that's a positive. And right here, it's a 0 at 2. After 2, it's negative. So the final solution, we want the product to be positive, right? So the solution to this inequality would be what? Negative 2 less than equals to x and less than equals to positive 2. Same conclusion. They should be the same conclusion, different approach. Do you follow me? To show work, okay, how much work do we need to show? Okay, I'm just going to give you a version of it, right? Solving this, okay, what work do you need to show? Hold on. I'm sorry about that. It's just sometimes it's just, okay, hold on. So here, from here to there, in terms of showing work, okay, I'm going to, I'm going to just drop these. You don't need to show these, okay? And you don't even need to show that. Okay, if you want to tell your reader you've done that, you can tell your reader you've done that. It's optional. Optional. Okay, if you are to show work, just go through these steps. Boom, 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 boom. You're done. If you choose to use this version. And next, I'm going to give you a third version. I'm going to give you the third version. Okay, each one of these will make connection to what we've done in the basics. Do you follow me? The next version I'm going to show you. It's here. This is the last version I will show you. You know, you can explore more if you want. Okay. Making connections with quadratic. From here, I'm going to divide both sides by 4 plus x squared. So from here, I'm going to just write 4 minus x squared greater than or equals to 0. I don't continue to factor anymore. Do you guys notice that? Isn't this a quadratic function? If I write it differently, do you see this? Do you guys see that? This is a parabola. This is a parabola that opens down. This is parabola opens down, and we want it to be greater than or equal to 0. So you're going to graph this picture, finding the x-intercepts, finding the intercepts. You have 2 points, and you want it to be greater than or equal to 0. Do you guys follow me? And of course, you just need to find the x-intercept. So you know, by this time we've been doing so much with this example, right? So the x-intercept, the 2 dots, is found, right? You get the x-intercept. And which part is positive? This part is positive, negative. What do we want? This is what we want. We want a positive or 0. So the solution is what? The solution is between -2 to +2. Do you guys follow me? All 3 approaches we talk about, the reason why I single them out is that we're making connection to what we have done. And these connections is omnipresent. It's always in your algebraic work. There are some connections. Remember, there are only 2 kinds of sentences in mathematics. 2. No past tense, no future tenses. Everything is present tense. Statement or if statement. Those basic things we have emphasized from the beginning of our time together. Okay? Now, of course, you will find x-intercept, right? You're going to say, oh, I'm going to find x-intercept. We have 2 x-intercepts here, which is going to set this equals to 0, right? And then you're going to find that x squared equals to 4. And, you go through the steps. So what I hope you guys learn is that you do you do the questions you've done, you work on the question you've done thoroughly. It is equal to, you've done 10,000 questions. Okay, you don't need to do 10,000 questions. You just do 10 questions completely, thoroughly. It's as if you've done 10,000. Okay, so you show some of these work if you wish. All I'm doing here is I'm trying to make that a connection. By making these connections, by making these connections, math becomes simpler. Do you guys agree? Okay, so you show the reader, you found the x-intercept, you mark these 2 points. So do you guys follow me? Okay, so you mark these 2 points. So can you tell me what are the solutions? The solution is obvious, right? Yeah, is the solution obvious?
Yes.
The solution is obvious. Okay. All right. Now, let's look at another one. Okay, we have a couple minutes left. Even though we did this question in, this similar ways you look is going to be, it permeates throughout the questions. Okay. You sometimes see these traces of similar questions. I mean, in academia, I mean, really, when you go to school, the question you see is just, you see a lot of quadratic. Okay, you see a lot of quadratic in different forms. Okay, as we go along, I will continue to point it out. Okay, so let's wrap this up. Okay, so it's a -2 less than equals to x less than equals to 2. So that's the 3 version. I hope you guys will study this. And I think if you do, you're going to benefit. You're going to benefit. Okay. What I mean by study is you do it by your own hands. You do it by your own hand. You don't just watch. Do you follow me? Once again, of course, that's my personal experience. I have to do it. I personally have to do it to get it. I assume that if you are not that genius, you will also have to do it to get it. Do you follow me? And if you are a genius and I'm asking you, so please don't come to my class because you don't need me. All right. Okay. So next, we've done this one question. We have so many interesting discussions and I hope this helps. Okay. And with the remaining limited amount of time, I think we'll probably continue tomorrow. I do want to talk about this number 3. I want to give you the other version of number 3 because I suspect that some of you will do that. Another way. Okay, let's come back to number 3. Again. I have given you a version of number 3. Okay. Unknown caller. Sorry. Another way of doing number 3 is some people will show it this way. Instead of showing not equal, they will show equal. And I believe this method was commonly taught by some teachers. It's okay. It's really okay. So what it says is that they try to identify the numbers to be excluded. Do you follow me? So if you show your work this way, it's okay. You have to understand when you make your domain, you need to do this. You set it equal to 0, you identify the number that make the denominator equal 0, but in your domain, you have to say it's not equals to the number. Make sense? So the logic behind is instead of not equal, so we look for its opposite. So there's a logical connection between these two methods. Do you follow me? And be aware of it. Okay, be aware of it. For the remaining of the time, I wish to do one more questions well, we'll probably have to do more tomorrow. I wish to take you guys to number 15. Okay, tomorrow we have a more task to do, and I really want you guys to get your hands on it. Okay. So this one I'm going to show, I wish to work with you is number 15. Okay. And this function, we call it g of t, is equals to, and this function is definitely from your calculus textbook. Okay. I have many in this section. They're from your calculus textbook direct. Okay. I didn't even modify anything. We are to determine the domain of this function. Okay. Next. So what you do on the setup, of course, we make the connection. We refer to and this basic function, right? And the domain is omega must be greater than or equal to 0, right? So we have that referral. You don't have to tell your teacher you have that reference, but in your mind you must have it. Okay. Now, but we have two square roots here. And you have to take care of both. In the first square root, the omega is 3 minus t. Sorry, it's 3 minus t. In your second one is the omega is 2 plus t. So you have to say that 3 minus t has to be greater than or equal to 0. And you also have to say 2 plus t must be greater than or equals to 0. The question is, what should be connecting these two? That is worth 1 point. Okay. The words connecting these two statements based on the basic function, this has to be and. If this and is missing or being used, if this and is missing, you're going to lose 1 point at least. If you use the word or, okay. If you use the word or, write it down. If you use the word or, you get no points. This is how you set up, okay? You get no points. You follow me? If you use the word or, then you say, what if I don't put anything there? Well, if you don't put anything here, I will have to look through your context. You know, I try to give you as many points as I can. So I look through your context. If you didn't have this and, of course, you're gonna lose at least 1 point. But I will still look at your context to see if I can have a glimpse of what's on your mind. It should be and or. Do you follow me? I will still try to dig up some more points for you. But if it's apparent to me that you meant an or, then you're going to lose all the points. If from your steps, there's a hint that you actually meant it's and, maybe you have some traces of that in your work, and I will try to dig a point or two for you, okay? So the best policy is to do this, really. Just put an and in between. Okay? what we need to know is that for all of these functions and more, when you are to determine domains and when multiple functions are involved, the connecting words is always and. The connecting words is always and. And if I am the person to grade your work, and I will be looking for it. If it's not there, you don't have the point for it. You follow me? Now, continue. Okay, you solve that inequality, you get a t less than equals to 3. And your n should follow you. Don't be lazy, write it down. Okay, and the other inequality you get t is greater than equals to -2. Combine these two, the final domain is -2 less than equals to t less than equals to 3. And you're done. Okay. Well, today, even though we only did a handful of questions, but a lot of material, a lot of issues being addressed. Okay, I want you guys to review the material, watch it over probably, if necessary. And if you have any questions, please don't hesitate. And today your homework is certainly going to be basic 19A. And I know keeping up with your homework is a lot of work for you, right? Yes? But you must. If you want to get that good grade in your calculus class, you must. You must. Okay? Anything we do in this semester, algebraically, is to prepare you algebraically for your next class. Provided you practice. If you don't practice those algebraic and don't reflect on those principles, and you're going to suffer terribly in our calculus class. Okay, and we're teaching online, so you don't have the opportunity to go just drop in a specific classroom with a professor teaching calculus and just drop in to watch what he's writing down on the blackboard or whiteboard. If you walk in, you're going to see the board is covered by algebraic operations. Okay, so you're working hard today. It's going to be beneficial for your tomorrow. Okay, if you trust me, okay. Once again, we're pushing the end of the class, and I will be heading to my office hours. And I appreciate your contribution, especially Cortland. I really, really appreciate. Okay, wonderful, wonderful contribution. And everybody have learned. I personally have learned from those mistakes as well, because at least it inspires me how I would guide you in my teaching, because the center of this class is you. Okay, the center of this class is you. I'm just here to help you, to point it out what is right, what's wrong, how you should do it, what's the principles, and so on and so forth. Okay, ultimately, it's your success will make me so proud. Okay, will make me so proud. Okay, so continue to make me proud. All right, I'll see you guys tomorrow. Have a great day.